But if we use a lot of server, the power is going to exceed 3000 watts. So what are we looking for is using the P state in the kernel itself to control the power, and then watching for the power graph characteristic when the power is going to go up or go down, so we can control the power more better. But what we're facing is the HPL and the server itself, when using P state a lot, the performance that we gain is not good enough when compared to use just only 4 nodes or 3 nodes with full power. So we decided we have to take out all the Xeon file that we asking for and some of the node and change the hardware configuration at the end. When it comes to NAMD and WolfCam, we didn't expect that we have a lot of workload to do. So when the workload is handling in to us, we look at the workload and see that many workloads has different of score. So maybe it indicate that each of workload have harder and easier to run. So our strategy is to run this easiest first and run them in all the nodes we have, so we might achieve the best possible. And for the WolfCam, because of the input is very large and the output is pretty large too, we create a remedy for WolfCam so we can achieve the better performance in theory. But because of both of these applications take compile time and we don't have enough time to do that, we have to change some strategy. So we facing with this scaling challenge of this workload. It's not scaling good enough for us that it actually gain performance when using a lot of nodes. Because when using one node and a lot of nodes, the timing is not better as we expected. So it would be smarter if we run every workload at the same time, just one node by one node. Yeah. So the second day, Palabas was learned from those applications. So what we looking for is run every workload at the same time, as we learned from yesterday. But before running, I have to tuning the Palaboy first. So I tuning all the Palaboy's workload in the morning and run in the late morning, like 9:30. But the problem started when we try to configure the secret application, because at first our InfiniBand was setting to run over the TCP. But in theory, if we run in native mode, it might be faster. So, and Palabot itself is using a lot of time to run. We have to decide if we want to really reconfigure the InfiniBand. We have to cut out all of the Palabots, and we actually did cut all of them out. And then becomes a secret application.
In the secret application with my work, the strategy is to reconfigure InfiniBand to use a Xeon file with a host, computing node, and tuning the MPI. The decision is I have to stop some parabolic work to reconfigure InfiniBand. That's what I said. And in the real implementation, we use the MPI combined with the OpenMP that we call the hybrid mode on the compute node. And we add the compiler fact that for more virtualized in our program and set environment for InfiniBand. And we found that to run in a symmetric mode with Xeon Phi is reduce the performance by Xeon Phi because the core in Xeon Phi is smaller than CPU, so it reduces overall performance. And then we talk about gridding. The gridding, we try to use the raw comment as much as possible, and then we reduce the result to the final result. in implementation, I force the task on the host to 24 threads, and in some rule, I vectorize it on CPU. Then move to coprocessor, which is Xeon 5. I use it 60 threads. But in Xeon 5, we can use a local memory because on Xeon 5, we have a very small memory. So we try to use remaining memory that we upload to the Xeon 5 to use as a local memory. But by that, we have to have a ratio that how much we have to upload the memory to Xeon 5 and to use on the host. So we make load balancing by profiling the test system with the various workload to get the ratio that we have to, how much we have to upload the data to the file and use on the host. By this objective to minimize the time that we execute the gating on the host minus the time that we use on the coprocessor. And let's move on. And that's it. And yeah, so after that we get the lesson learned from this challenge. The first, I found that some technology that like a hyperthread or many core is not work in some case. Like a symmetric mode that I found that is slower and it's reduced the overall performance. Then in the system design, like for example, in the NAMD application, then the application have to connect to many servers and we have to increase more port. So we have to reconfigure something and the workload planning for each application. Some workload I don't have time to run because our plan is not good enough. So this is our lesson learned from technical things. And for the teamwork lesson learned, we know the teamwork and the body working. I do and he shake, I do, he shake, I do, he shake, and then we learn the statistic decision for balance working. Then and we handling some unexpected situation like that, and the knowledge and social benefit.
In final of this day and yesterday, what we gain is a lot of stuff we have experienced in this competition. We have a better skill with HPC stuff like how the server is run, how the power management has to do, what they have, and what the actually server having and provide us if we actually have those things. And the skill that have to be used when reading about application and running about application. And for the others, we would like to thank you guys for giving an opportunity to be here and having a new friend, new life, new culture, new toilet. And we very enjoy being in China, especially the food and people is very good here. And very great party show. So thank you for everything and thank you for everyone.